Okay, now we have two problems to work on. So stop the video, work these two problems, and then we'll go over your answers and I'll work them. We'll compare the two answers. So assuming you've done the problems already, here we go. Notice that there's a difference between these two problems. They're both integrals, but this one has the upper and lower limits of integration. And from the previous video, we recall that the answer to this one is going to be a number. So our answer should just be a number, 10, whatever the number we find it is. This one, however, we're looking for a function whose derivative is equal to the original function. And we're going to use the rules in video 2 or from your book, which you have hopefully memorized, because we do need these skills in order to be able to perform integrals. Okay, so one of the rules we had allowed us to break up plus and minus, and we can also move constants out in front. So this particular one can be broken up as the integral of 3 times x to the 4th minus the integral of, what's another way of writing square root of x? Well, of course, that's x to the 1/2 power. So we get the integral of 3 times x to the 4th minus the integral of x to the 1/2 power plus the integral of 2. And these are all from our basic forms. X to the 4th will be x to the 5th over 5. Because the rule is n, we move to n plus 1 in our answer, divided by n plus 1. So n times the 3 minus, same thing for x to the 1/2. We add 1, so we get x to the 3/2, x to the 3/2 power, divided by 3/2. Help if I write it the proper way, 3/2. But dividing by a fraction is the same as multiplying by its reciprocal. So there's no real reason to write divided by 3/2 when it's going to be the same thing as multiplied by 2/3. And then plus the integral of 2. 2 is a constant. The integral of a constant was kx, so 2x plus a capital C. So, and one way to check your answer on an integral is the derivative of this thing must be the first function. And we can kind of see that happening. Derivative of this will be 15 divided by 5, or 3x to the 4th, and so on. You can take the derivative of each piece and check your answer. Now we're going to introduce doing this one by hand, although in the next video I will show you how to do this on a calculator as well. This is an area under a curve. The answer is a number, and the calculator is very efficient at calculating approximations to these. But we can also do this by the same type of techniques. X to the 2 on the bottom is the same thing as x to the -2 on top. And so now we take the integral. This is a power rule, so I add 1 and divide by the same number. So x to the -2 plus 1 would be -1. Divided by -1 would simply make that negative. Dividing by negative is the same as putting a negative in front. And we write this in a particular way. This is the antiderivative of that, but we're going to evaluate it from 1 to 5. And this notation here means I'm evaluating this function from a low value of 1 to a high value of 5. So what we're going to do is take our function and plug in 5, the high value, and then subtract the same function. So we do have to be careful with our negative signs. I'm subtracting a -3, so that will of course turn into plus plus. And -1 power would simply put that on the bottom. So I have -3/5 plus 3 over 1, or 3. And well, what does that come out to? Well, obviously putting this over 5, I would have 15/5 minus 3/5, or 12/5. So my answer to the area under this curve is 12/5, and we'll momentarily check this on our TI-83 calculator.